reasonably readable and everything's coming through?
Looks good to me.
All right, does the zoom it work properly? Am I all the way down in the bottom right-hand corner?
Yes, you are.
Excellent.
Excellent.
Okay, so that should be that. That should be that. All right. Well, shall we get started, Belinda? You want to kick us off?
Let's do it. So I'm going to let you introduce yourself, Andy. Go ahead.
Okay, well, my name is Andy Yoon, and this is GroupBy 2021. I'm closing out the Americas session today. I have a little bit of a bio slide a little bit later, but if this is the first time you happen to be joining us this evening, welcome. GroupBy does happen to have a code of conduct that we ask you to abide by. In a nutshell, just be good to each other, all right? In either case, we must also give a nice shout out to all of our different sponsors who have helped make this event possible and give you all of this free content. Thank you so much to all of them. We really appreciate you guys. All right, so without further ado, let's dive right on into missing indexes, do's and don'ts. My name is Andy Yoon, and I'm going to be soon a field solutions architect. I actually start on Monday with Pure Storage. But the thing is, for the course of my career, I've been working with SQL Server for quite a while. If you're familiar with any of the presentations, you'll know that T-SQL internals and tuning and indexes are kind of my bread and butter. And that's where this particular presentation kind of came about. Of course, I'm pretty active on Twitter. You see my Twitter handle down at the bottom, and in addition to my email address. And the other most important thing is my GitHub. Everything is based around my Twitter alias, SQL Beck. So that's really all you have to do is, or just remember that, no C in the SQL Beck. But in either case, you can Google that and you'll be able to find information about me, including this presentation, demo scripts, and all that other kind of good stuff, which will be up on GitHub a little bit later. I'll get back to that. But without further ado, let's get on into the presentation. So start thinking to yourself, how do you react when you see something like this? Some of us have different types of reactions, and to share about myself, I had a different type of reaction whenever I saw a missing index recommendation at different points in my career. Early on, I'm like, oh, hey, a missing index recommendation. This is great. The optimizer is going to help me out. I'm going to apply this now. Cool, right? But then, as I learned a little bit more about missing index recommendations, I kind of realized that there's some caveats to them. So my opinion swung from one extreme of, oh, let's make use of this, to the other extreme of, oh, these are worthless garbage. Ignore these. I don't want to make use of these at all, right? There's a lot of issues with these sort of things. And then as time went on, and as I gained more experience as a developer in DBA, I kind of found that middle ground, if you will, and to help you kind of to help figure out when to make use of them and how to best make use of them. And that is the purpose of this presentation. So to accomplish all of this, I'm going to go over our agenda for today. First, I'm going to do a quick recap of index access methods because there's some fundamental concepts that I need to make sure that everyone fully understands and fully appreciates. And then we're going to dissect a missing index recommendation and what it's all about and all the underlying key pieces of information that it can give us. I'll also cover some caveats and drawback. And then the second half of this particular presentation is going to be all demo, where I'm going to be demonstrating and talking about and exploring a lot of the stuff that I'm covering in the first half in the lecture portion. I always like to level set that that this particular presentation is a 200 level session, meaning I expect you to at least be familiar with the basics of indexing, like what's a clustered index, what's a non-clustered index, key columns, included columns and such. We're not going to be talking about column store today. That's outside of the scope of this presentation. And then also I want to be extremely clear. This session has absolutely nothing to do with how to create the perfect index. That topic is a complete session in of itself. There's some different fundamentals and different concepts that I'll kind of touch upon that relate to how to craft an effective index. But again, that's not something that we're going to be diving into today. I'm really just going to be focusing around making the best use of these missing index recommendations. Okay, so with that, let's get started. First, I want to talk a little bit about index access methods. And if you know me in any of my presentations, you'll know that I love analogies. So for today's presentation, we're going to be using that of a cookbook. This particular cookbook is one that's on my shelf downstairs, and we got a table of contents right here. Now that little photo is not all that readable, so here's a more readable version of it. But the table of contents in a book of any sort lays out the order of the contents of that book. So one of the things I used to say was that the table of contents is kind of akin to the clustered index, but that's not entirely accurate. The clustered index encompasses both the table of contents and the recipes or the contents of the book itself, okay? Because you got to remember that the clustered index is the table itself. It's just a form of the table, or the form that the table takes when you create a clustered index. You're ordering it by something. And then, the different page numbers are actually dictating, the logical order, and so on and so forth, right? Now, in the back of our little cookbook, we also happen to have an index of some sort to help us find different things. This particular cookbook just happens to have indexes on different key ingredients in this particular example. So for, I've zoomed in here, we have garlic, for example, and then we have a list of underlying recipe names. And you notice that all of these different elements are sorted. So, there's lemon and parsley butter, there's ginger and soy marinade, gremolata, and all these other different things, but those are all sorted elements, right? So in essence, this is like a non-clustered index that happens to have two key columns, okay? And then it also happens to include another piece of information, the page number, which is kind of like our clustering key, for example, and it's what allows us to jump back to the actual recipe itself. And that's kind of how a non-clustered index works. So the thing about an index of some sort is that it helps us find what we want, but we have to navigate the index. We have to follow a certain set of rules and as we scan through and skim through that particular index. So this is the index that we're going to be using, for the next handful of slides, and I want to walk through these different examples and different points. So from an index key column perspective, we have the key ingredient. In this case, I'm only just showing you pork right now. And then underneath that, we have subcategories here. And notice that these are in order of chops, ground, loin, and ribs, okay? And then underneath that, we have specific recipes, which again are also ordered values, okay? So again, this my non-clustered index essentially has these three different keys. It's a hierarchy, and that's one key thing that you need to keep in mind, no pun intended in that case. And then finally, we have included columns. These are a couple of extra data points copied out of the original recipe that are just there for as extra reference points. But these are not really ordered or anything like that. They just happen to be appended onto the recipe name. So in this case, we have the type of meal it is, like a dinner or an appetizer. We have the cook time, and then we have the page number itself. Okay, so now that we've broken all of that down, what I'm going to do is I'm going to give you a handful of different tasks or queries and talk about how we navigate this index in order to find exactly what it is that we want. Now, remember that we must follow this structure because honestly, when humans read this, it's a lot easier just to jump exactly to where we want to go. But a program, something like SQL Server, has to follow a certain set of rules. So in this case, it must use the index key columns in order to navigate this index. So if I happen to be looking for roasted pork loin with herbs, I first have to go to the first element, the key ingredient, which I know is pork. And then I know that I'm going after a loin, so I go to the subcategory loin, and then I know the rest of the recipe name, roasted with herbs. So I'm able to seek straight into the recipe that I want. This is fundamentally or logically equivalent to that of an index seek operation within SQL Server. I have all the pieces of information. I can navigate straight down and boom, I can get at exactly what I need. Now, the next query that I'm going to throw at you is pork appetizers. Okay, well, here's where all the different appetizers are, but I never specified a subcategory. I don't know which subcategory or categories my appetizers happen to reside in, right? So I can start at pork, but which one of these subcategories do I go to? Unfortunately, I have to go to all of them. So this is logically equivalent to that of an index scan operation. So, we're scanning through all the pork recipes because I don't know where the appetizers are. There could be one, there could be many of them, right? So I have to check each and every entry. Similarly, what if I'm given a query that says all ground meat? Remember, we're just looking at a subset of this of my cookbook um, index here, right? And we just happen to be looking at pork elements, but my query does not even specify the type of meat that I want. So I can't even use the key ingredient. It just says I want all ground meat. So I have to scan not only the pork section, but everything. So I'm looking after chicken, I'm looking after beef, I'm looking after anything that is a meat or a protein in this particular case in order to find all the ground elements. So again, another logical variation of a full index scan. Okay, I am taking a few liberties here, so if some of you might be like, wait a minute, yeah, I am taking some liberties. This is an analogy after all. I just want you to understand the concepts for, again, those of you who are not necessarily familiar with how these all work. Okay, another query. So now I want to hunt around for ground pork ravioli fillings. Well, I know pork again. And then I know that I'm going after ground recipes. And then I know that I'm going after ravioli fillings. Well, there's a couple of ravioli fillings entries. So I can seek to the first entry, and then I can scan to all subsequent ravioli filling recipe entries thereafter. This is called a range scan operation. Even though if you look at it inside an execution plan, this will look like an index seek. And only if you go into the properties will you actually see that this is truly a range scan operation, because it starts as a seek and then it scans some data. A second example of this is, let's look after all pork loin recipes. So I know go to pork, go to loin, and then I can just scan all of those. So that's more of a range scan scenario here. And depending on what or how you order your key columns, a range scan can be an extremely powerful tool in figuring out, how to make indexes that are effective for your workload. Because if you have a lot of inequality predicates, like, a recipe was submitted after or within the last 30 days, right? So I want a range of something, then, having that date submitted key column, being somewhere as a second or third key column can be very crucial to help you accommodate that range scan operation, because we can seek on the first couple of key elements and then we can scan on that date submitted. But if the order of those are different, am I able to do that range scan operation? Things to keep in mind. Okay, couple more. Or actually, this is the last one. So I want to look for honey glazed pork spare ribs. However, I also need the calorie count. Well, okay, well, this particular non-clustered index, I can definitely seek to the spare ribs honey glazed recipe, but in the included columns, is there a calorie count available to me? No. So in this case, I must execute what is the equivalent, logical equivalent of a key lookup operation. I must now open up the cookbook and jump to page 84, and then I can scan the recipe itself. It's an extra step, extra work that I must do, because the calories value was not included in this particular index. Included columns are a little bit of a trade-off. We can't put an entire copy of the recipe, into our indexes, but we should or try to put the values that are most often referenced by the vast majority of our queries and our workload, right? So it's finding that balance, because everything is always a little bit of a trade-off. All right. So in addition to all of that, one other thing that you want to be very mindful of is how unique are your different key values, particularly the first one, because it's that first key value that will help you eliminate a whole other chunk of that index, if you will. So if we're still using that key ingredient, let's say, I'm looking after shallots. Well, there's only one entry here, and I'm looking after sherbet. Well, there's 3 entries here, right? But then if I'm looking after pork, there's a whole heck of a lot of entries here. If the vast majority of my data happens to be like pork, where I have many, many, many different recipes, it's not very selective. It doesn't have a high cardinality to it, which means that the index is not going to be nearly as effective. I'm still going to be able to do a lot of scan operations, hopefully scanning a subset of the data. But in an ideal world, I want to consume the least amount of data possible to find the data that I want, right? So that's why everyone seems to love index seek operations, right? So if I'm able to seek because of the choice of key columns, and if those key columns are highly selective or very unique or have a high cardinality, all of those terms are synonymous, right? Then that gives me the capability to seek into my data faster to find exactly what it is that I need. You can't always seek, but you want to try and maximize those whenever possible. So just to kind of recap, I want you to be mindful. Of how seeks and scans navigate an index, particularly the range scan operation, because that's something that can be very, very useful and beneficial. Is one of those things that's overlooked on a fairly regular basis, in my opinion. And then, hopefully these couple of examples can, give you the sense of how key order and cardinality can make a difference. Because again, if my index starts with something that only has maybe 3 unique values across millions of records, well, then it only cuts the index by maybe a third at best, right? Or something like that, or 1 of 3 possible values. I'm not narrowing things down on a very effective basis. So if you have low cardinality leading key, for example. All right. So with that, let's now dive into the internals of a missing index recommendation. I want to introduce the DMVs that are in play and start breaking everything down. So first of all, when you're looking inside Management Studio, this is what a missing index recommendation, of course, looks like. It's going to give you a non-clustered index suggestion with some columns in there and oftentimes some included columns. It's also going to give you a percentage improvement that the query optimizer thinks is going, this non-clustered index will help your query by. This is called the impact. I will get back to this shortly. But first, let's meet the DMVs that are in play. We got sysdmdb missing index groups, missing index groups stats, and then missing index details. So the index groups DMV is actually just a simple DMV of just a couple of different keys that join to the other DMVs. The only key data points that's important about the missing index groups is that it has the unique identifier of the missing index recommendation. Okay, so you can find that there. But let's now dive into the other 2 DMVs and find out what kind of key information that is available to us. First, we have Dmdb missing index group stats. And of the key different columns here, really what we're going to be, what's most useful to us is the seeks and the scans. The user seeks and the scans. Usually we don't care about system seeks and system scan information. But this is going to give us an idea or a sense of how often will this missing index recommendation improve? What types of different operations will it improve? These different seek operations and or scan operations, right? And that's essentially what it boils down to. The last user seek and the last user scan can also be very helpful to tell you if a missing index recommendation is stale or not. So the missing index recommendations basically don't get cleared out unless you blow away the underlying indexes. And the underlying existing indexes, therefore invalidating the execution plans, or you reboot your SQL server. So you could have missing index recommendations that applied 3 months ago or something like that, right? So always be mindful of the last user seek and user scan. Now, unfortunately, it doesn't give you an idea of volume, but it at least tells you if something happened recently or not. Now, the cost and impact metrics are also very, very important here. The cost, or the average total user cost column, refers back to the query cost that you see in your execution plan. Remember that query cost and execution plans is a unitless value. Everyone has their own little favorite slang term for it, whether some people like to call it query bucks, other people like to call it farkles or query tiers or whatever you want to call it, whatever silly name you want to give it. But that is the raw value by which the SQL Server Query Optimizer believes this missing index will improve this query. So if you have a query whose estimated cost is 1,000 units, and you have a missing index recommendation that the cost improvement is 900, that's a whole heck of a lot. Because the thing is about the cost is that the cost value in of itself is, there's a lot of different schools of thought as to how useful or worthless is it. I at least find it valuable for looking at things from a relative perspective, right? Especially when I'm looking at multiple different queries within the same workload, within the same server, and that sort of thing. So for kind of from a relativity perspective, but you can't get, so in either case, the thing about impact, though, is that's a percentage change. So if I have a very low cost query, maybe a query that costs me 10 units, and the cost change from the missing index recommendation happens to be 5, wow, that's a 50% improvement. But it's not that much of an improvement in the grand scheme of things. When I happen to have other queries in my workload where the costs alone and the differentials are in the thousands or tens of thousands or hundreds of thousands even, right? So, again, a raw value of like 5 or 10, that's a drop in the bucket, right? Unless that's what the entirety of my workload happens to be. That's why you kind of need to take these a little bit with a grain of salt and understand what your workload happens to look like. Okay, the other DMV is the missing index details DMV, and some of the key data points in here are the equality columns. So this is essentially the definition of the missing index recommendation. It's going to give you a comma separated list of equality columns. And when I say equality columns, these are the columns where you have a predicate with an equality operator, where last name is equal to Yoon, where key ingredient is equal to pork. So, anything is equal to something else, hence an equality column. So if, those are in your query, they will manifest in your missing index as an equality column. And then afterwards, you have inequality columns. So it would be a comma separated list of any columns in the missing index recommendation where you had some kind of inequality predicate of something greater than, less than, not in, or something like that. And then finally, a comma separated list of all included columns that the query optimizer would love the non-clustered index to also have as well, in addition to these key columns. Okay. Now, this is all well and good, but there's one key bit of information that's missing from these 3 DMVs. These DMVs are reporting your missing index recommendations from a workload or a server level perspective. It gives you no information about which exact queries generated which given missing index recommendation. And that has always been a bit of a challenge. Thankfully, SQL Server 2019 introduces yet another DMV called Missing Index Group Stats Query. And this can be very, very powerful because now it's going to give me much of the same information that you found in the index details DMV. However, it's also going to be on the query level now. And then I can join Group Stats Query back to dmexec SQL text in order to see the exact statement that generated that specific missing index recommendation. And this makes things, in some regards, it kind of changes the game on things. So it's something that I think is really, really powerful and can be very, very useful. And you'll see a lot of this in the demo coming up. So I just showed you a whole bunch of really cool things, right? I mean, there's a lot of fantastic information inside these missing DMVs. So what's the downside? Why do I dislike these? Well, unfortunately, the missing DMVs themselves and the missing index recommendations have a lot of caveats. I want to focus on a handful of them in the course of our discussion today. First of all, inequality columns. Microsoft clearly states in their documentation that the cost impact when it comes to inequality columns is flawed. It doesn't tell you by how much. It just tells you that it's inaccurate. So kind of take it with a grain of salt. Gee, thanks. That's really helpful. So that tells me that I can't rely on these at all, right? Well, maybe not at all, but be mindful of the fact that the cost and the impact may not be accurate when it comes to inequality columns. So another reason to take that cost and impact with a grain of salt. Now, this is one that really, really, really grinds my gears. The recommendation column order. Oftentimes we'll see a non-clustered index that'll have 3 or 4 or 5 key columns. Did you know that the order of those key columns as presented to you is not the ideal column order? It is an arbitrary ordering. There's actually a rule set behind it, and we'll see this in demo shortly. But the point is this: if you happen to have a missing index recommendation that's got 4 columns, you can't take that at face value. You need to actually look at the underlying data of those 4 columns and figure out, is this actually a good hierarchy? If I go back to my analogy from earlier, it'd be like me taking the key ingredient and putting that as the last thing rather than the first thing, and then putting recipe name as the first key, which would help me if I'm querying for a recipe name, but it's not going to be very useful if I'm looking after some of those other generic, more general kind of queries, like all pork loin recipes or something like that. So if my leading key happened to be recipe name, that's pretty terrible for me, right? So understand that the column order as generated by the missing index recommendation, that is truly garbage. And again, I'll show you exactly what happens and why. The other key caveat to remember is that a missing index recommendation is tied to an execution plan, not a query. What do I mean by that? If you're familiar enough with execution plans, you will know that you could have multiple different queries that all generate the same execution plan. And then you should, if you're familiar enough with execution plans, know that there's a very common challenge when it comes to dealing with execution plans and plan catching, something called parameter sniffing. So that, the first time you run a given query with a certain set of parameters, it's going to generate an execution plan that's compiled for those set of parameters. So that missing index recommendation is good for that execution and those parameters. But then that execution plan is going to be reused by other queries that may have different sets of parameters. And that is where things can really, really go sideways. So understand the missing index recommendation and its scope can be a real big challenge. And then finally, understand when the execution plan is created. It is created by the query optimizer when it's parsing everything, and then it's handed off to the storage engine for actual execution. And how many times have we written a query and we see SQL Server start to run it, and wow, this is taking a whole heck of a lot longer than we expected. That's because all execution plans are fundamentally estimated execution plans that are generated by the query optimizer based upon things like statistics. It's making guesses, educated guesses using statistics and things like that, which also means that your missing index recommendation is derived from potentially inaccurate information. Well, Andy, what about using an actual execution plan? An actual execution plan is a bit of a misnomer. It is the same thing as a regular old estimated execution plan. However, myself and some others in the industry, we prefer a different term. An actual execution plan is better phrased as an execution plan with runtime statistics, okay? But it's fundamentally still the same execution plan, and the missing index recommendation that's inside that execution plan will never change after execution. So SQL Server can't say, oh, this was really terrible after I finished execution, I should give you this other missing index recommendation instead. There's no going back in that sort of sense. So because of these different drawbacks, especially the fact that these things are built around execution plans and not specific queries, we got to be mindful that, I may happen to have this query here, this author summary query here, but it could be executed many, many different times with completely different sets of parameters, such as, different states, different dates submitted values, and so on and so forth. In fact, we're going to be using this piece of code and exploring this during the course of our demos. So to that end, let's, let me just do a bit of recap here. So you want to be mindful and reconsider, the bigger picture when it comes to a missing index recommendation. You must consider how frequently it's being used, its scope, its context, and so on and so forth. And hopefully the demo scripts that I have will really drive these points home, okay? But keep these things in mind as we get into the demo, which starts right now. But I'm going to take a quick 10 seconds to see if there are any questions in the chat or in the Q&A panel. I don't see any right now, but I'll take a quick sip of tea just to give everyone a chance to throw any questions in that you might have.
I have a question for you, Andy. This is
Please.
Linda. So my question would be, how frequently should you go through and check on your indexes to see if there's any improvement that needs to be made?
That's a fantastic question. So One of the things, so, you can look at missing index recommendations from a query level perspective or from a workload level perspective, right? And what you're talking about is what I would classify as doing a workload analysis on a periodic basis. So personally, I'm a big advocate of doing it once every couple of months, but it also depends on your application release cycle. Because here's the thing. One thing that I've seen so many times over the course of my career is that, you release, an application or, a build or whatever, that has a certain set of queries, and maybe you've taken the time during that release to build and craft some indexes that work well with that workload. Great. So you throw it onto production. Maybe you want to do an assessment after the first couple of weeks because your users start using your application in ways you don't necessarily expect. So sometimes it's useful to do that analysis. But then later on, maybe that build stays in production for another couple of months, and then a new release is put out. And in that new release, you have some new functionality. You have some add-ons to some existing functionality, things like that, which require you to modify some of your queries. But how often do you go back and also modify the non-clustered indexes that originally supported those queries? Oftentimes, in my experience, that's overlooked. So the next time that build goes out, now you have queries that have, that, for example, maybe calling for extra columns. And then now you have those non-clustered index that used to cover the query, maybe it no longer covers it. So now you wind up with things like key lookup operations suddenly popping up in your workload and things like that. So I like to try and do it after, a couple of weeks after a major release to, again, kind of get that, baseline of what has changed before and after. But that's how I like to approach workload analysis. Does that help?
Yes, it does.
Outstanding. All right. Doesn't look like there's any other questions in the chat or the Q&A panel. So I'm either doing a fantastic job or you're all asleep. So no worries. And feel free to heckle me or whatever and have some fun. Make comments or observations as we are going on through the chat. That's what I typically like to do during the live presentations. But with that, let's jump over to the demo. So first of all, I'm just going to quickly introduce a couple of diagnostic queries. I'm not going to spend much time on these. These are things that are available up on my GitHub. But this particular query happens to be based upon a query that was originally written by a gentleman named Bart Duncan back in 2007, because that's how old the original missing index recommendations happen to be. One of the key things out of this particular diagnostic query, and I'll run it in a few moments to show you what's up, is that Bart came up with something called an improvement measure that looks at total user cost, average user impact, and then user seeks, and then user scans, as an attempt to kind of come up with some kind of raw number to help us measure whether a given missing index recommendation is actually something that's really valuable because a lot of my workload happens to be using it, or whether it's like, oh, this has only popped up a few times, you probably don't care about it, or like, the relative cost improvement is trivial, or whatever the case may be, right? So I can run this right now. And I've run some workload in my environment before this presentation. So now you can get an idea of some of the underlying data. The index group handle is that unique identifier for a given missing index recommendation. Here's that raw value, that improvement measure that was a calculated value of some sort. We have our list of equality columns and inequality columns, included columns, and then I scroll further to the right end, there's other data points such as, the user seeks. And then if I scroll even further, you'll see where the cost and impact information happens to be. Now, this has been all fine and dandy and useful in SQL Server 2017 and prior, right? Because again, this is what looks at things from that workload perspective. However, I'm now going to switch to a different file, diagnostic queries 1A, where now I'm going to integrate in the new index group stats query DMV. So now we can see query level information. This one is an aggregate version of that prior one, but now I can see the number of different queries that leveraged a given missing index recommendation, or that generated a missing index recommendation. So, oh, hey, not only is this improvement measure really high, this is used by a lot of different queries, right? So now I have a better sense of, oh, this is something that I may want to pay more attention to, right? As opposed to some of these guys, oh, this happened only once. Now, granted, some of these may the ones that happened only once, maybe I want to dive a little bit more into the underlying code. And that's something that I can do by grabbing this index group handle now and then digging in deeper. So let's see, that index group handle was 10. So then I would just add in a predicate here, and I can do that. In this case, I just happen to have all of these right here. So, for example, there's going to be over 100 of these different entries. And as I scroll further over to the right, let me show you how. So we have the SQL text right here. So if you were to actually expand this fully, you'll see that the SQL text, the predicates vary ever so slightly. And then I slightly renamed each of these different major columns. So I put in a prefix for the aggregate or the workload level type data points, and now the query level one. So these are query specific. So now I can break these down and then extract out, maybe one of the queries has, 5,000 or 500 million user seeks as opposed to everything else. Oh, that's the one I really want to zero in on. Or maybe that's the guy I just want to spend some time tuning too, right? So I do see there's a quick question in the Q&A panel. I think enterprise-wide they block purposely. Can you please share the link to GitHub for code? So everything is under my alias SQL back. You'll see that on the final slide as well. But SQL BEK is my online alias. So you'll be able to do that. And if Belinda, if you want to type the answer into the Q&A panel, because again, this U40513 person does not have access to the chat. All right. Cool. So again, that's just a quick introduction of these diagnostic queries. You can spend some time going over these queries a little bit later. And just so you know, if you go to my GitHub right now, you will not have the latest version of these scripts because this is the first time I'm presenting this particular presentation. So you're seeing the debut of it, but that also means I was actually making last second changes up until the last hour. So I'll be uploading everything, this particular iteration, to GitHub later tonight. Okay. All right. So let's, in our next demo, explore the whole notion about key order, right? And credit to Brent Ozar and Brian Reebok, who kind of dissected some of this stuff in this particular URL here. And this is where I happen to learn about it, because I didn't know about all this information until relatively recently, until this bubbled up on social media. So we happen to have two tables in this particular example: keys ascending and keys reverse, where all of the columns except for rec ID are either in alphabetical order, A, C, D, P, R, S, or reverse alphabetical order, SRP, blah, 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 right? So we got these different tables in here. I've created a clustered index on each of them, and then I've dumped a bunch of data into them. That's really all you need to know about it. But again, remember that the columns are either in alphabetical ascending or descending, okay? So this is just a quick reference here if you happen to be going over to the demo and wanting to do this again later. So first of all, I'm going to turn on actual execution plan. And I have three different predicates in here. Remember, there's no non-clustered indexes on this guy. So in this case, because I have three equality predicates, I would expect that the query optimizer is going to give me a missing index recommendation because it wants to do a seek, and it wants a non-clustered index to support this in order to do a seek. However, if I look at the execution plan, I found that I do a full clustered index scan, and there's no missing index recommendations here. When I first started messing with this, I'm like, what gives? Why? I totally expect a missing index recommendation. Then I forgot the devil is in the details. I love that particular phrase. And in this case, the details happens to be the properties tab. So I'm going to open up the properties tab. I'm going to reselect the select operator. And the data point that's important here is optimization level. The query optimizer can go through multiple different levels when it optimizes your query to generate an execution plan. One of those optimization levels is trivial. If the query optimizer says, I can just generate a trivial plan for this, it's never going to give you a missing index recommendation. In other words, you will never get missing index recommendations on trivial execution plans. So even though I know that I could get a missing index recommendation that can definitely help this query, you're never going to get one. So that's the first gotcha. Always double check what these happen to be. When I was doing my rehearsals, I actually kind of forgot about this, and I spent 15 minutes pulling my hair out before I remembered, oh yeah, this is what I wanted to teach in this particular demo, right? Okay, so from here on out, you're going to see this really weird clause here. Please don't use this in production code. I'm just using this in demo to force the query optimizer to go into full optimization. That's the only thing that it's doing in this particular case, and that's it. So now if I do this, Now I have some missing index recommendations generated in each of these different queries, which I would fully expect because again, I have no non-clustered indexes. Let me minimize the properties tab to show you the interesting bit. In the first case, for the keys ascending, my non-clustered index recommendation is author first name, category, and date published. However, for the table where the columns are in descending order, notice that these are also in descending order. The secret behind the missing index recommendation and the query columns that they will recommend to you is that it is presented to you in the ordinal ordering that you have created your table in, and that's it. So again, in essence, it's somewhat arbitrary. It's not random per se, but it's basically just whatever, so it'll say, you want to use these columns, but I'm just going to give them to you or spit them out in the order that they are defined on the table, which again, may or may not have any relevance whatsoever to the cardinality and to the usefulness of each of these different data points. So this is something that can burn us. Okay, so let's take a look at the underlying query, the DMV query. This is a subset of it, and we're looking at the 2019 version of it. And you see how in the equality columns, I have a data set here that, again, shows me a CSV list of the 3 equality columns in ascending order and then in descending order here. I'm using these labels, by the way, to help me just kind of query against them. That's just part of the demo here. All right. I'm going to skip this optional demo, but basically one common question that I got when I was rehearsing this was, hey, does the order of the predicates make any difference? Shorter answer is nope, it doesn't change anything at all.
There was a question out there, Andy,
yes,
from Ash. I'm not sure if you tackled it. I don't think you did. Those low to no use indexes, I think he meant maybe those new to no use indexes may want to consider dropping to improve write performance, especially if they have more active tables, right?
That is absolutely correct, Ash. And I'm going to kind of indirectly tie back to this, but that particular talking point. But in a nutshell, I have an older, different presentation, which will be part of the resources later on, called Duplicate, Missing, and Redundant Indexes. So yes, I do talk a little bit about missing indexes in that particular presentation, but it's also about the duplicate and the redundant and unused indexes as well. So there's an entire presentation all about that. But yes, you're absolutely correct. You do want to try and also evaluate your index workload every now and then to try find indexes that are really no longer being used by your workload, because that's just worthless overhead, right? So why bother maintaining them if your workload is not benefiting from them? But again, that's a little bit of a tangent, but it's a fantastic question. All right. So coming back to the demo here, I'm going to we're still working with the keys ascending and descending. And now I'm going to add in a range predicate on the protein column. Protein is greater than a value of 6. And let's see what we happen to get here. If I look at the execution plans, and if I just look at the little summary here, my first keys ascending, author, first name, category, date, published. It's all in order as I would expect it. But these are not in order. I see D, C, A, and then protein. Well, what gives? Andy, didn't you just talk about how the column order in the missing index recommendations will always be defined as the order of the table and everything like that? Well, here's the thing. Remember that there's 2 sets of columns that are returned: equality columns and inequality columns. And it is within each of these individual sets that the columns will be ordered either in the ordinal ordering of the underlying table. So that's why in the second case with the descending column table, it went with the equality columns first in descending order, and then it went with protein down here. Okay. To further drive this point home, I'm going to now change category name to also be an inequality predicate. And we'll run this really fast. And in this case, once again, I have my equality columns in alphabetical ascending order, and then my inequality columns in ascending order. And then same goes down here: descending, equality, descending, inequality columns. And if you run the DMV query once again, you'll see the same underlying behavior in there as well. So I'm going to skip that for now. So in either case, hopefully now you have a better appreciation of the fact that the key order in a given missing index recommendation is in of itself kind of garbage. So you need to take the time to say, okay, of these different keys that are being recommended, I need to take a closer look at them, right? Okay. So with that, I'm double checking the Q&A real fast. Doesn't look to be any Q&A. So let's move on to our next demo, which is just an individual query. So now we're going to go back to that one query from earlier that I showed you in the slides, the author summary. And then I have 3 different variations here. The first, so you don't have to worry about the select portion, really just worry about the predicate here. In this particular example, we have authors, state, not in a couple of different states, and then we're doing a comparison against dates submitted is greater than a value, and then the approved value is equal to 1. So we have a couple of an equality predicate and then a couple of inequality predicates. That's the first query, V1. Notice the label here. V2 is very similar. However, we have some different state values here. And again, this is a not in clause, not an in clause here. So this is an inequality predicate. But instead of 2 states, now I have a couple of dozen here. Everything else has stayed the same. That's variant 2. Version 3, now state is an equality predicate where state is equal to Illinois. Okay, so I'm going to run these guys 3 times over. That's the go 3 quick shortcut or quick cheat, and then we're going to run my diagnostic query thereafter. 1, 2, 3. Let's run all these guys and let's see what gets generated for those. Okay. So we see that this is clearly an example of 3 distinct different queries that generated an execution plan that all had the same missing index recommendation. So, this is a simple example of that. We have slight different variations of them. I didn't parameterize anything, as you saw. So these are effectively, remember, 3 different queries in here. And if I scroll further to the right, you'll see the different query hashes as well. That further proves that, right? And then, notice that, I can look at some different aggregate information and query information. Notice that aggregate user seeks is a whole heck of a lot higher. That's because there's actually other workload in my workload that I ran earlier that also leverages this specific missing index recommendation, not only these particular 3 example queries here. But again, this is a simple example where the query specific versus the aggregate and comparing and contrasting that can actually be very, very helpful. So keep that little tidbit in mind. Okay, so the recommendation in of itself is to create a non-clustered index on the approved column, date submitted, with and include these 3 other different data points. So what are the underlying data types in the in this particular table, in the reviews table? Let's quickly check. I'm going to use SP help real fast just to quickly show you. So in this case, date submitted is a date time data type, and then the approved column is a bit. So in this case, approved can only be 2 possible values. It's not even nullable. So it can't, so it can never be null. So it is fundamental. It will always be 2 possible values. Is that highly selective? No, right? Well, let's take a look and profile our data and take a look at that a little bit closer, right? And by the way, what were our test predicates again? In this case, we're always looking after approved is equal to 1. And then we're doing some kind of, date submitted is greater than, 2019, January 1st or something like that in this particular case. What do you think is going to be happening in the actual execution plan underneath it? It's going to be a range scan operation. If we're able to create a non-clustered index that happens to have approved dates submitted, right? And wouldn't that still be good? Well, probably, right? But what would happen if I happen to have the opposite? keep that in mind. So sorry, I skipped ahead as I was talking. First, let's quickly review the underlying data just so I can show you, well, how unique each of these different things are. As far as different distinct approved versus unapproved reviews, the vast majority of my 1.5 million or 1.4 million records, the vast majority of them are approved reviews. Only a small subset are not approved. However, my date submitted is highly selective, right? So of the 4 million or 1.4 million records I happen to have here, just under that is how many distinct date time values I happen to have here. Remember, date time. There could be more distinct dates, but my data type is a date time data type, right? So I could have hundreds of reviews on the same calendar day. That's a key detail here. So this may not be as distinct as we hope, but this is good enough to illustrate the purpose and the point of, should we create a non-clustered index with approved first and date submitted second, or date submitted first and approved second? Think about the access methods that we talked about earlier. And again, I kind of cheated and got ahead of myself when I kind of mentioned that a range scan is kind of ideal in this particular scenario. But let's prove it by testing. So I'm going to create two non-clustered indexes. Note that the name just has approved date submitted and then the date submitted approved, okay? So we'll create those two guys right now on the reviews table. And we are done. And now we're going to rerun all of our different test codes. So we got, V1, V2, and V3. Let's see what happens here. Going to take a look at the actual execution plans, and the operator on the reviews table in the first query happens to be an index seek operation. However, what is it? Notice the seek predicates here. When you see key predicates down here with something like this, that is your hint that in this case, this was actually a range scan operation. You can also see this information if you were to go into the properties tab of the index seek. So I'm going to go in here. I'm going to go down to seek predicates. And you see how it talks about, as I dig in and expand each of these, we have a range start here. And in this case, it's this scalar value in this particular case. Scan direction is your other key kind of giveaway in here. So if you see that we're scanning the index either forwards or backwards, because yes, SQL Server can also do a reverse range scan. So those are your key hints to see that, oh, actually, this really isn't truly a seek. This is a range scan operation. All right, real fast. And by the way, which index did this one use? This one used the one that led with approved date submitted, which is actually what I would expect in this particular scenario. Let's take a look at the second example real fast. We also have a similar index seek, which really is a range scan operator down here, and it's also going in against approved date submitted. Do you think we'll have the same behavior with the third one? Well, probably. So I have yet another index seek here. And yet again, this one's going against approved date submitted. So this is a case where having the column with the highest cardinality as the first leading key column actually doesn't really help us that much, right? So this is where you need to make that judgment call and understand your data. Now, as a separate side topic, this is actually a great case for potentially using a filtered index, but that's a separate topic in of itself. But, and again, I'm not getting into what would make the best index, just how to evaluate this missing index recommendation, right? So I'm not going to address filtered indexes. The other key thing to note is that these different queries have now generated another missing index recommendation. How many times have you guys seen that? I've seen that plenty of times where it's like, oh, I applied this one missing index recommendation. Now a new one shows up. Well, what gives? Okay, well, now this one's on the authors table where I'm looking after state. Well, that makes sense. The authors table doesn't have any non-clustered indexes on it, and I have some both inequality and equality predicates on it. And because I have both inequality and equality predicates on it, note that when I look at the missing index DMVs now, we have seemingly two different missing index recommendations because the first two queries had the inequality and the third one had the equality predicates here. So one key detail, notice how the unique identifier or the record ID of the missing index recommendation, the first two happens to be the same and the third one is unique. Okay, so even though the non-clustered index definition in and of itself is identical functionally because it's just that single column index, in this case, there are actually two different missing index recommendations. More of a little bit of trivia and just something to appreciate when you're looking at the missing index recommendations, especially when it gets to looking at things from that workload perspective, which we will get to a little bit later. All right. So we got two other queries that are variations of the first one. Now I'm going to add in one more new predicate on the author's first name. And in this case, I'm going to use a wildcard where it's like the letter A. And then the state is still going to be Illinois or equals Illinois. And the second one is going to be like something else, but it has the same pattern, like Amber in this example. But then the state will have a like pattern here instead of an equality pattern here. So that's query number 4 and query variant number 5. Let's run those. Now, if we look at the different author recommendations, this isn't so for query 4 and query 5. Notice that we have state first name, but because the other two are now inequality predicates, now we're getting bitten by the fact that the two columns in question are in the same grouping. So therefore, the ordering happens to be defined as the ordering within the table. So first name state, it just happens to be the order of the table. Is that the best order, or is it state first name? Is that the superior order in this particular case? Again, you want to take a look at the data and then figure out whether you're going to benefit more from an equality predicate or an inequality predicate. And this is also where you're going to want to look at your workload, look at, the unique compiles and the volume of seeks and scans and that sort of thing to get a better sense of is this particular query or, ones where you have equality against state, is that what happens more frequently in your workload? Or is it the other variant where state is an inequality or a not in? Does that happen more frequently in your workload? Or do both happen so frequently in your workload that you may actually benefit from adding both variations of these? That's where, again, you need to look at your workload and some of the other different data points here. In this case, we just executed these queries. So, I mean, they've been executed twice or once. All right, so I'm going to create all 3 non-clustered index recommendations that were laid out. The one with just the state, the one with state first name, and the one with first name state. Okay, let's rerun variant 1 through 3 first, the ones that did not have any predicates around first name. Execution plan. And then if I look at the author's operation here, the first one is looking after author's state, where I happen to have these particular predicates here, and we see that this is exactly what's going on because I have a not in, or wait, was this one the Illinois or not in Illinois? Sorry, I actually forgot. Let's go back and look. Not in Illinois or Wisconsin. So it's an inequality predicate here, okay? Oh yeah, I could have also cheated and looked at the properties tab and said, oh, hey, look, we're actually scanning forward in this particular case. So it's a range scan. Okay, that's what I was trying to reconfirm. But the second variation is actually a full index scan here because we have so many predicates and so many state values that we're looking at not in that SQL Server says, you know what, forget it. I'm just going to read everything in this non-clustered index. At least this non-clustered index fully covers the query, but I'm just going to scan everything. There's no way I can do any kind of individual seeks and scans and that sort of thing. And in this case, it's looking at first name state, not the state first name non-clustered index. And that's kind of interesting because first name is not used at all by this particular query. So but sometimes the optimizer will choose one of those other non-clustered indexes. In this case, it's probably just close enough, good enough, and that's probably what happened here. The third one, we also happen to have an index scan operation once again. We're again going after the first name state one. And again, we have a very similar kind of predicate behavior here. Or, oh, wait, I didn't scroll down properly. Silly me, I apologize. This is the third query here. I was wondering about that one because whoops. It's getting to be the end of the day, right? We're all getting punchy. All right, hang in there with me. We've got a couple more demos. So this is where I'm doing state is equal to Illinois. So now we have a true index seek operation. This is what I would expect. And then if I look at variants V4 and V5, going to execute these guys here. So When I look at the execution plans, in a nutshell, yes, we are using the new non-clustered indexes as I would expect them to against the authors table. Here we go, state first name here, and then first name state in the other example. Because remember, one of them had an equality predicate and an inequality, the other one had two inequality predicates. The key takeaway, though, from me rerunning this once again is that yet we have another new missing index recommendation that just popped up, another one on the reviews table. What gives? So this leads to the question of how far do you keep going and how far down the rabbit hole do you continue? And this is where you want to look at the output and of the missing index recommendations and actually look at the underlying cost values. Remember how I talked a bit about how cost and the relative costs, it's one of those relative measurement type of things, right? So in this case, the improvement cost, even though the percentage impact would be very, very high, it's not even one query unit. Do I really care about that? That's really trivial. If this was 32 bazillion, then yeah, I would definitely care about this missing index recommendation. But now this is the whole idea of, like now we're really splitting hairs here. So you know what? This is probably a missing index recommendation that's not really going to help me all that much unless I have the edge case of this piece of code being something that's used insanely frequently by my workload, but very rarely is that the case. And this is one of those points where I'm like, you know what? I hit that good enough point. It's not worth the trade-off of creating yet even more indexes. It's not going to give me enough return on investment in this particular case. So this is an example where you want to take a quick glance at that cost value. All right, there's another optional demo in here. I don't have the time to do this, but basically it's talking a little bit about the unique compiles and that sort of thing. So you can come back and kind of take a look at that. It's a different indirect way of measuring how often a query is being used. But I want to move on to the fourth demo, which will be a fairly quick demo. The last two demos should be a little bit faster. And this one is all about using Plan Explorer. Ooh, what's that all about? Okay, so here's the deal. So when you're looking at a missing index recommendation inside Management Studio, what I've been doing up until this point is kind of cheating. I've just been looking at the missing index, as it's been generated right here, right? And it's just showing me one missing index recommendation. There's a couple of other different options that I could do. I could right click on the first operator here, the select operator, and click on missing index details, right? I'll do that. I'll click on that. And then I have a single missing index recommendation here, right? Not so fast. I like the phrase the devil is in the details, because if you really dig into the details, and there's a couple of different ways to do it, of course. The first is by opening up the properties tab. Let me pin this out. Open up the select tab. And then if I open up the missing indexes section, there's not one missing index recommendation. There's actually 4. But Management Studio in its infinite wisdom hides these from you. The only way you can see that you actually had multiple missing index recommendations is by looking at this panel or by looking at the underlying, XML. Why is this tab thing popping up like that? There we go. I'll stop that. All right, so I'm showing the plan XML, and then now you see the missing indexes section in the XML, and now we see the first missing index recommendation, the second missing index recommendation, and so on and so forth. So the thing is, most of us are not going to be shredding XML. I don't know about you, but I hate XML, right? So instead, what I'm going to advocate for is making use of SentryOne Plan Explorer. Plan Explorer, if you're not familiar with it, is a completely free tool. It's great for dissecting execution plans. I have an entire advanced Plan Explorer presentation that's floating around out on YouTube. But one of the key things that is inside Plan Explorer that you will not find anywhere else is something called index analysis. And this is something that can be very powerful, and you can leverage this as a kind of a sandbox or a worksheet to play around with those non-clustered indexes. First of all, though, I am going to click on the plan diagram here and right-click the missing index details note here. And note that within Plan Explorer, we don't try and cheat you. We will show you all the missing index recommendations that were generated inside the execution plan XML. Now, in order to make use of index analysis, I do need to get a fresh estimated or actual plan. So I'm going to go up to the results tab, right click, copy statement to command text, and then use estimated plan to execute or parse, I should say, what's inside the command text, which is my underlying query, this guy right here. So we're going to do the estimated plan. And the reason Plan Explorer needs to do that is that in addition to getting a plan and the missing index recommendations and stuff, Plan Explorer also grabs histogram information about your statistics, which is also another key piece of information that you need to better understand whether a given index or something like that can be useful to you or not. I'm going to jump over to the nutritional information operator over here because this is one of those guys that actually had 2 missing index recommendations there. So I happen to have, this particular, this is the clustered index as it was defined. If I scroll a little bit further over to the left, you'll see the different column names and that sort of thing that are in play. So this particular clustered index is just on nutritional information ID. And then I happen to have 2 missing index recommendations here. And here's the different key columns that it happens to want. And then it also wants some included columns here as well. So if I scroll back further over to the left, it's saying, I want to look at, calorie information and or, the recipe IDs and stuff like that. And then as I click on different elements, like the different columns or the index in question, I'm going to see the a visualization of the statistics histogram. So, there's entire sessions all about just statistics alone, of course, but this is a great utility to be able to make use of this to play around with all of that. I don't have time to deep dive into this particular bit of functionality. There will be more information forthcoming in the resources slide where you can then learn a heck of a lot more about leveraging index analysis. Okay, and there's some optional stuff of like, hey, if you decide to use Plan Explorer, you can continue down the path of creating a non-clustered index definition in there, applying it, to the server, and then actually making some changes and continuing on there. But in this case, in the interest of time, I want to jump to our final demo, which is a little bit of overview about the workload analysis bit. So, we're using this cookbook demo database once again, and then, I always like to start with the aggregate query version first, and I'm using the updated one for 2019 that actually has the aggregated number of queries here. So I'm going to run this guy first and foremost. And then what I like to do is I actually like to copy and paste all this data out and dump it into an Excel document, which I happen to have right here. I already have this Excel template that has all the different columns set up and that sort of thing. So that way you can see exactly what all's going on here. And then this way I can spend some time filtering and focusing in on the different missing index recommendations. I can sort them by the improvement values, or maybe I want to look at the number of queries and, I start spending some time slicing and dicing each one of these. Maybe I want to filter out ones where the last seek or the last scan was more than a couple of weeks ago. Maybe I only want to focus in on one particular table at a time. I can leverage Excel to do that, right? Or, one thing I might do is, sort all the different table names by A to Z and then sort, the different equality and then inequality columns. Whoops, let me do it this way. I'm going to go to the custom sort where I can do, add level. So we'll do this by table name. We'll do this by equality columns. And then inequality columns. The reason I like doing this is that sometimes you may have missing index recommendations that are very similar to one another. So that way, then you may decide, I can kind of mash these guys together. Well, a simple example here, I have a couple against recipe ingredients where the leading key column happens to be, or the leading equality column that's being recommended to me is the ingredient ID. And then I have one variant where it wants quantity and unit as included columns, and another variant where it just wants it as inequality columns versus included columns, and another one where it omits it entirely. So if I consolidate these 3 together, then I know that, all 3 workloads can benefit from this particular missing index recommendation. Now, I wish I could spend some more time on this exercise, but this is, again, where I'm referencing back to that other presentation of mine from a couple of years ago, where I walk through this workload analysis process in greater detail and depth, and actually talk about finding these and this is where the whole concept of duplicate and redundant indexes also comes into play as well, because now I can review these missing index recommendations, figure out which one of these are semantically duplicates and or effectively redundant or overlapping, and then then, kind of from that workload perspective, I can mash some of these guys down. That's essentially what I'm trying to do here, is figure out, okay, of all the ones that are generated by my workload, I can actually consolidate a couple of these and create, a better index that would cover more of the workload that is being that is demanding or requesting these particular missing index recommendations. So that's just a quick overview of that. So, oh, whoops, I goofed up the animations here on this particular slide. One of the changes I made earlier today, but as I just mentioned, there is an older session out there about duplicate, redundant, and missing indexes. Here is the URL for that. Again, all of this stuff will be up on my GitHub shortly. I'm going to package up the latest and greatest that we just finished up, and I will be publishing those there, including this URL. I strongly encourage you to watch this particular presentation. It's a really good one, and by adding on not only what I covered today in great detail about missing indexes and then leveraging the new information that you have in 2019, but then combining that with the duplicate and redundant knowledge will help you do that workload analysis if that task happens to fall or come your way. All right. So as we kind of wrap things up here, I want to leave you with a handful of different parting thoughts, some do's and don'ts. Don't ever, please, take a missing index recommendation at face value. I hope that I've been able to prove to you through the caveats and some of these demos that a missing index recommendation on the surface is truly worthless, right? But do consider the missing index recommendations in the course of the context of the missing index recommendation, how frequently it's being utilized or requested, I should say, and by analyzing your underlying data to see, what really here makes sense. So these missing index recommendations, I want to focus on the word recommendation. Think of it as an optional recommendation or be under advisement, right? There's all sorts of different metaphors or phrases or whatever that kind of describe that. Take this into consideration, but never take it at face value. One story that I would love to share is that I had worked at a company once that they brought me on as a SQL Server expert, and there was a big shop of .NET developers for a SaaS product, and they were having horrific performance challenges and problems because it was all ORM based, right? And one of the problems is that they never had a really good indexing strategy. Well, the infrastructure manager at one point when they were having a massive production outage basically said, you know what, we have these missing index recommendations, apply them all. And I said, whoa, wait, are you insane? Don't do that. But of course, he was further up the food chain. So he said, oh, these can't hurt. Just apply them all. And he overruled me. And while it fixed some problems, it took me many, many months thereafter to consolidate and rip a number of them out because it caused other problems on the back end. And there were hundreds of missing index recommendations that wound up getting applied blindly. And that was not a lot of fun. So please never take them at face value, but do take the time to consider them because they can give you valuable insight about what your workload may need to help it. So typically I do have a learn more resources slide, but again, as I admitted earlier, this is the first time I presented this. So this will be coming soon. I hope to have this done in the next couple of days and a new version of the slide deck posted. And again, where you can find everything is up on my GitHub. All you have to do is remember SQL Beck, my online alias. So, keep this in mind. This is also in the next slide, which is where I say thank you for joining me today. Now, please, because this is the first time I'm giving this session, I'm going to beg you for some feedback here. First of all, if you have any specific feedback, I'd love to see it in the chat. If you do not have feedback, please just give me a quick I either type like a +1 or a -1 or a 0 in the chat right now, just to give me that quick sense of, hey, did this meet your expectations, exceed your expectations, or if it didn't meet your expectations? That way I can just get a quick gauge. So again, just a quick +1, 0, or -1. I would really appreciate that if nothing else. But again, if you have more detailed feedback, I would really appreciate it to figure out other ways that I can further improve this presentation. So thank you for that. And then otherwise, I'm hanging out for questions and stuff like that as well. Whew.
And the mysterious U40513 also said it was a great session.
Well, thank you very much. I really appreciate it. So. Excellent. Thank you all for the feedback. I really appreciate it. So I'm glad to hear that your head was spinning. That's one of the things I tend to do in some of my most of my presentations, that I do overload with a lot of material, and I am notorious for going fast. It's one of those things I've just come to accept about myself. I'm a fast talker, and I generally make 75-minute sessions and try and cram them into 60 minutes. Because I could very easily have spent more time on demo number 4 and demo number 5, for example. But I hope you guys learned a lot from this about missing indexes and how they can be useful, and why they should never be taken at face value is really the one thing I always recommend. So thank you for the feedback. Thank you for the pluses or the minuses in the chat.
Your story is very scary that someone said, just apply them all, just do with it. I mean, that just made me cringe.
So the better part about that company as well, when I first showed up, an executive had basically mandated that the ORM code should never leverage stored procedures either. Everything must be overarm generated. I'm like, wait, what? What did I just walk into? I mean, I knew that I was joining this company as a SQL Server performance tuning expert to help clean that stuff up, but it took me 2 years to override that manager. And the way I had to override that manager was that we had a massive production outage, and I snuck some code into production. That was a store procedure that fixed the issue in a like super fast. And so I obviously went rogue. I broke some rules, but I saw the production outage. So the executive's like, all right, Andy, you finally made your point. I'll start allowing some store procedures in there, and then I quit.
It's like the code equivalent of wrapping a pill in provolone cheese before giving it to your dog. You're like, yes, those updates I intended to do.
We wrap it in cheddar.
Cheddar, there you go.
I'm cheap. I just use American cheese.
Yeah. Oh, that was so great. I've already poured myself a glass of red. What a great way to close out GroupBy. Oh my goodness, I can't believe from beginning to end, Andy's been here, still so awesome for this session. Belinda, you are the ultimate hype woman of all time moderators. I was loving seeing you on Twitter. I was like, note to self, feature her any moderator slot she wants. Such a rock star.
Well, it's fun because I could just unmute and interrupt them and ask them a question. And I am the perpetual 3-year-old. Why?
I love that. That's exactly what we want people to do. Because if you're thinking it, other people are thinking it, and it's good just to be like, no, why is that, right? Like, and a lot of times the presentations, you have to move so quickly. So it's nice to have those little moments where it's like, wait, can we go a little deeper on that? Like Andy was saying, like 75 minutes squished into 60. It's great. It's great for the flow. And I love those little beats where we can just dive a little deeper on those items like that. It's awesome.
Well, Andy is a ball of fire. He is just a ball of fire, and it just is fun watching him, and very passionate.
Well, thank you very much. I really appreciate that.
Absolutely.
One thing I'll mention about the whole questions thing, sometimes I get a little nervous because oftentimes in my presentations, I actually don't get that many questions. So does that mean I put my audience to sleep when they're not paying attention, or like I'm actually being comprehensive enough that, oh, I am answering the questions that wind up coming up, like, like you get a question on this slide, but I wind up answering it on the subsequent slide. That's what I try to do with my presentations. I try to build on the things or revisit the things that I have, before and after and that sort of thing. So that's at least what I strive for. Hopefully I've been able to accomplish that, but
I think no questions means you're like, I love the ones that open up room for it, but when you're like going deep dive, super complex, super engaging, and you get no questions, I think everyone's just kind of like,
yeah, I think it's
like it needs to digest.
I think it's fire hose, and it's in a good way fire hose, because you're creating, at least in my mind, you created a lot of questions and a lot of thoughts, things I want to go think about, that you have to walk away from your desk. So yeah, it was quite fascinating. So I think that's what people are feeling. So the no questions in your case, when they're light, I think it's because you're just creating a little bonfire in each of us that we have to, nurture.
Oh, I love that.
Thank you very much. I'm very flattered. I really appreciate it. So.
Yeah.
Well, thank you everyone for joining us for GroupBy today. I am so thrilled with how today went. Everyone did so amazing, so many awesome sessions, and it's not over yet. We've got Europe just around the corner, and T minus, oh my gosh, I think it's T minus 7 hours till that. So any of you night owls that's looking for some more content, or early risers that want to stop by for the last few sessions of the day, good news, we'll be having those available shortly. Make sure you take a look at the attend page. We've had some last minute changes to the schedule, nothing too major, but make sure you know, some sessions might not be where you think they are. Take a look. Either way, thank you all so much for an amazing day. And I think I'm going to stop the recording, and I'm
Not
going to
just
go.
yet. One final thought. I just want to have a shout out to you, Jeremy, for all of the hard work that you have put into this particular event, because you are, one of the foundations of GroupBy now, for better or for worse, whether you like it or not. So thank you for all of the hard work that you have done for each and every one of these that you've been involved in. So thank you.
Oh, my heart, you're so nice. Thank you. Honestly, it really takes a village. It really does. And we've got
toast to you.
But a village needs leaders, and you are one of those leaders.
I love GroupBy.
We do too.
We do too. I love it.